Okay, so today we're talking about how to graph rational functions. We spent all of last week talking about their properties. Like all functions, they have x and y intercepts. These guys also have horizontal and vertical asymptotes. Sometimes they have slant asymptotes. Sometimes they have removable discontinuities, also known as holes. And we're going to use our knowledge of those features to help us graph the function. So the very first thing we're going to do is factor the top and bottom of the fraction. We're going to factor the numerator and denominator. Because finding all of my asymptotes, finding my intercepts is typically easier to do in factored form. Finding my holes, I need it in factored form. So we're going to factor first. Next step, we are going to find and plot our vertical asymptotes. And our horizontal asymptotes. Horizontal, I know how to spell. You should also identify your holes at this stage, as we know that we find holes at the same time we find vertical asymptotes. We're going to plot them later. So at this stage, I'm finding where my asymptotes are, and I'm going to my graph with a different color and making dotted lines for all of my vertical asymptotes and my horizontal asymptote if there is one. Yeah? Okay. Next step, same idea. I'm going to find and plot my intercepts. Both x and y. We know our y-intercept happens when x is 0. Our x-intercepts happen when y is 0. And that's going to give us a pretty good idea of the shape of our graph. But typically there's one more step that we want to do, which is to make a table of values and plot those extra points. So we're going to pick some x values in each chunk of our graph, because our asymptote divides our graph into chunks. I'm going to plug those x values into the equation to find the y values that go with them. I'm going to plot those points on my graph to help me flesh out what the shape looks like. We're going to do 2 examples so we can see how this process works. Yeah? I see some nodding. Good. We're going to start with the example from quiz 6, now that you've seen it. So our first example, we are going to graph f of x equals, and if I remember correctly, it was 2 over x squared minus 3x plus? Plus. Yes, plus. Thank you. Oh, that is the worst plus I've ever drawn. Long day. All right, I'm going to follow the directions we just wrote on the board together. So first step is to factor. Check the numerator first. I can't factor 2. 2 is a number, constant, he hangs out. Check the denominator. What can I do with the denominator? Factor out an x, yeah. Both those terms have an x in common. So x squared divided by x is x. 3x divided by x is 3. So x times x plus 3. What? You multiply that out, you distribute, get back to where you started. Yeah. Good. Second step says find and plot vertical asymptote and horizontal asymptote. So we will start with our vertical asymptote. Vertical asymptotes are the non-cancelable zeros of the denominator. The no-no zones in my domain, not allowed to divide by 0. So, for vertical asymptotes, I can have x equal to 0 or x plus 3 equal to 0. X equals 0 is solved. Y-axis is an asymptote. X plus 3 equals 0 gives me what? X equals negative 3. Good. So 2 vertical asymptotes. My graph is in 3 sections. Everything less than negative 3, everything between negative 3 and 0, everything bigger than 0. 3 chunks. 4 horizontal asymptotes. To figure out where my horizontal or slant asymptotes are, what do I look at in my original function? Raise your hand if you remember. What do we check? Marissa? Good. Very good. We look at the leading coefficient, top and bottom. We look at the degree, biggest exponent. So in the numerator, which is a constant, what is the degree? Ooh, x to the 1 is x. I don't see an x up there. So what power of x gives me 1 as an answer? 0. Yeah, this is degree 0. Constants are degree 0 because there is no x. Yeah. What's the degree of the numerator? 2. Perfect. X squared, biggest term down there. So looking at that, numerator degree is smaller than denominator degree. What does that tell me about my horizontal asymptote? I hear Marissa mumbling something. Yes? So y equals 0. Very good. Num degree is less than denom degree. Top is smaller than bottom. Y is equal to 0. So I can start graphing before I make my table of values. I'm going to scooch you sideways. Maybe. Come on. Oh, the lag is going to kill me. Come on. There we go. And we will see if it remembers that I copied a graph from earlier. No, it did not. Oh, frowny face. Okay, I'm going to have to draw from scratch. Let's sigh. Let's sigh. I'm going to mark my asymptotes. It's a good first step. X equals 0 is the y-axis. I have an asymptote here. I have a vertical asymptote at x is minus 3, which is here. I have a horizontal asymptote at y equals 0, which is the x-axis. Step 2 is done. Yay! Next question, what is step 3? Aubrey, what is step 3? Very good. Find and plot our intercepts. So I know my y-int is where x is equal to 0. So if I plug in x equals 0, what's my denominator? If x is 0. 0. Am I allowed to divide by 0? No, that means I don't have any. Not allowed to divide by 0. There are none. I can see there are none because I have an asymptote on that axis, meaning I shouldn't touch it. Same thing for x-intercepts. X-intercepts y is equal to 0. Looking at that function, are we ever going to cross the x-axis? No, why no? Because there's an asymptote there. Very good. We started off by saying we have a horizontal asymptote at y equals 0. I'm never going to cross it. There are none. There is no value of the numerator that will make that fraction 0. The numerator is a constant. The numerator is always 2. And remember, it's the zeros of the numerator that tell me where my intercepts are. That's what makes the fraction equal to 0. Good. So no intercepts. Now it's just a table of values. So I'm going to do that below my table, x, and then f of x equals 2 over x squared plus 3x. We're going to pick some x values. So don't groan. You know how to do this. We have 3 areas, so we should pick points in each area. To the left of -3, I'm going to do 3 points just to get a feel for what's going on there. So my instinct is -6, -5, -4. And that'll bring me up to my first vertical asymptote. I picked them because they're less than -3. I want areas in the leftmost section of my graph. To find them, we take the x values, we plug them into the function, they spit out some y values. So -6 times itself is 36. -6 times 3 is 18. 36 minus 18 is 18. 2 divided by 18 is 1 divided by 9. If you do not believe me, you are welcome to grab your calculator. Yep, we're just plugging it in. Substitute in the formula, spit out a value. 5 squared is 25. 5 times 3 is 15. 25 minus 15 is 10. 2 over 10 is 1 over 5. 4 squared is 16. 4 times 3 is 12. That's 2 over 4, which is 1/2. Again, please feel free to grab a calculator, check my math. I am sleep deprived. It could be wrong. But I did this in 4th period and nobody complained. So I'm assuming that's probably correct. We will get there in a minute. One thing at a time. So I'm going to put those on the graph. -6 is almost 0. 1/9 is pretty small. -5, it's at 1/5. -4, it's at 1/2. It's increasing by just a little bit every time I get closer to the asymptote. So it's going up this way. And I know that it flattens out along that horizontal asymptote. Yay, 1/3 of the graph is done. That makes us happy. Next section, there's only two nice pretty integers between -3 and 0. What are they? -1, -2. Perfect. That'll take us to our next value. We're going to do the same thing. We're going to plug those into the formula. 2 squared is 4. 2 times 3 is 6. 4 minus 6 is -2. 2 divided by -2 is -1. And we repeat. 1 squared is 1. 1 times 3 is 3. 1 minus 3 is -2. Going to be -1. 2 divided by -2 is -1. They are the same. They are down here. And I know I have some limitations. I can't go above the x-axis. It's an asymptote. And I know that I'm trapped between -3 and 0. So I have a sneaking suspicion that my curve does this. Just based on where those 2 points are sitting. Yeah? Not pretty, not perfect, but it's as close as my little freehand is going to get. Is the peak higher or lower? All right, last chunk. I need numbers bigger than 0. 1, 2, 3, because those are in order and they make sense. And we repeat the process. We plug them into the equation. 1 squared is 1. 3 times 1 is 3. 1 plus 3 is 4. 2 divided by 4 is 1/2. You can check me, but I happen to recognize the symmetry. I know the next one's 1/5 and then 1/9. Again, plug in your calculator if you do not believe me. Which means on the right side of the graph, we're starting out at 1/2, and then we are getting smaller. So my graph is doing this. For those of you who tried to answer the quiz using a graph on your calculator, does that match what you saw? Yay! So knowing those asymptotes, knowing our intercepts, knowing where our holes are helps us get a lot of information about what the picture looks like. Then we just got to flesh it out with some extra points. Let's try another one. Yeah. So example, we want to graph the function f of x equals -3x plus 6 divided by x squared plus x minus 6. We're going to go around the tables. Jackie, what do I do first? Very good. First thing we're going to do is factor, top and bottom. Starting with the numerator. Do those two terms have anything in common? 3, very good. I know I like my leading terms to be positive. I'm going to factor a -3 out, because that'll make the leading term in that binomial that's left over positive. So -3x divided by -3 is x. 6 divided by -3 is -2. Then the same thing with the bottom. The bottom, we can play the x game. Factors of -6 that add to +1. So factors of 6. I would go 2 and 3, or 3 and 2, yeah. And then the question is, if I want them to add to +1, which one should be negative? 2, the smaller guy. -2 plus 3. When we check, we FOIL that out, we get -2x plus 3x. That adds to 1x. -2 times 3, -6. Check. Perfect. Do you see anything up there that cancels? Yeah. Common factor of x minus 2 on top and bottom. So the reduced function is just -3 over x plus 3. And that tells me, for my next step, I know I have a hole at x minus 2 equals 0, or x equals 2. I'm not going to do anything with that yet. That's going to come later. But I need to remember that when I go to draw my graph. I canceled the x minus 2 term, so that's where I have a hole. Vertical asymptotes. Julie, how do I find my vertical asymptotes? How do I find my no-no zones? Okay, and then what do I do with it? You're thinking horizontal asymptotes. What am I not allowed to have in the bottom of my fraction? 0. Can't have 0. So I need to know where x plus 3 is equal to 0. -3. Perfect. Vertical asymptote at x equals -3. For horizontal asymptote, Julie is correct. We need to look at the degree back in the original function of numerator and denominator. So for the degree of the numerator, degree of the denominator. Megan, what is the degree of the numerator? 1. Very good. What about the denominator? Denominator. 2. Very good. So I can see that numerator is smaller than denominator. Who can tell me what our horizontal asymptote is? 0. Very good. Degree of numerator is smaller than degree of denominator. So we have a horizontal right on the x-axis. Perfect. Which means when I go to step 3, I don't have to do any math for my x-intercepts. If my asymptote is the x-axis, will I ever cross it? No. I know this is going to be none. I also know that because if I look at the reduced fraction, -3 over x plus 3, there's no x value that's going to make that numerator 0. It's always just -3. So no x-intercepts. Ooh. Brandy, how do I find my y-intercepts? Y-intercepts happen when x is equal to what? Yeah. Good. So we're just going to shove 0 in for x. And you can do it in the first formula or the second. I'm going to do it in the reduced. 0 plus 3 is 3. -3 divided by 3 is -1. I'm pretty sure we're going to end up with a y-intercept of -1. Yay. So let's graph that. So we'll start with the asymptotes. I have a vertical at -3. I have a horizontal at y equals 0. And I have a y-intercept at y equals -1. So I know I cross here. So, okay, Alex, what's the last step? Step 4. Very good. Make a table, find some points, plot them in the graph. Very good. I am going to use the reduced equation because it is easier to evaluate. I should get the same answer as if I use the unreduced original equation. The only place they will disagree is at our removable discontinuity, where we have a hole. So I need a couple of numbers smaller than -3. My instinct is -6, -5, -4. I'm going to give you a minute to figure out what those f of x values are that go with it, and then I will call on some people. Just a few more seconds. Okay, we're going to start with x equals -6. At x equals -6, what is f of x, Bruno? What did you get for that first f of x? -1/1 is -1. Do we agree with -1? I see shaking head no. I think we're close. I think it's going to be positive. Good. Good. -6 plus 3 is going to be negative on bottom. Good. Very good. Aubrey, what'd you get for -5? So -3 over -2 is 3 over 2 is, I'm going to go 1.5 because I think that's easier for my little brain to graph. I agree. Very good. Luis, what did you get for -4? 3. Perfect. So we've got enough information to plot the graph to the left of our vertical. -6 here is 1, and then 1.5, and then 3. Come on, pen. Come on, pen. Looks like that. I have a sneaking suspicion of what the other side looks like, but let's find some values. -2, -1, and I'm going to skip 0 because we already have a 0. That's our y-intercept. So just 2 values. If I plug in -2, -2 plus 3 is 1. -3 divided by 1 is -3. If I plug in -1, -1 plus 3 is 2. That's -3 over 2, which is -1.5. So -3, -1.5, and then at 0, it's 1, -1. So this side of the graph is this way. There is one more thing my graph needs. What is it? Who remembers? The hole. Very good. We had a removable discontinuity at x equals 2. So I'm going to go back in now that my curve's drawn, and draw the hole. The other way you can find the hole is by plugging in that x value into the reduced function. I know my hole is at positive 2. 2 plus 3 is 5. Negative 3 over 5 is negative 0.6. And that hole is sitting at a little above negative 1. And that matches what we see from the reduced function. So you can draw the curve and then erase to make the hole, or you can plug that value in to find the exact coordinates of the hole. All right, your homework this week. You have 3D part 2. Go back here. That is practice on the graphing part. That's due next Monday. No, next Tuesday, because I don't see you next Monday. It's a 3-day weekend. You get an extra day off because the end of the quarter. I know, I feel it too. You do have some homework due today. 3D, which is a practice with those asymptotes and holes from last week. That's due today. If you were here on Friday for the vertical maze, please turn that in today. If you have questions, I have a meeting immediately after school, but starting at about 4:30 onward, I'll be available in ASB. Okay? Otherwise, you can catch me tomorrow morning or send me an email. Yes.
Do you also have a day off on Monday or no?
Do I? What? Huh? What? Huh?
Do you also have a day off on the next Monday or no?
Next Monday is a holiday. Nobody's going to be here.
So you get to rest at least?
Hopefully. That is the plan. Because my college course also ends on Friday, so I should be done with my double duty. Yay.